In this video, you will learn about how to attempt some basic MCQs of carbohydrates. Let's start with the first MCQ. The general formula of monosaccharide is option A CnH2nOn, option B C2NH2ON, option C CnH2O2n, and option D is CnH2nO2n. So which one is the correct option? The correct option is A. The option A is the correct option, which is CnH2nOn. N indicates the number of carbon atoms. The carbon atoms for monosaccharides, it ranges from 3 to 7 carbon atoms. The N indicates the number of carbon atoms. Let's see here if the carbon atoms for the carbon are 3. If the number of carbon atoms present in the monosaccharides are 3, then if we put them in this formula, which is the general formula for monosaccharides, this N indicates the number of carbon atoms. If the number of carbon atoms is 3 and we put the 3 instead of this N, this number, then it will be C3, and then 2 into 3 is 6, H6 and O3. And if the number of carbon atoms are 5, then if we put it in the formula, it will be C5, H2n, then 2 into 5 is 10 and O5. And if the number of carbon atoms are 6, then if we put it into the formula, it will be C6, 2 into 6 is 12 and O6. So it will become C6H12O6. Question number 2 is compounds having the same structure formula but differing in spatial configuration are known as option A stereoisomers, B anomers, C optical isomers, D epimers. The right option is stereoisomers. Stereoisomers, as if you can see here in these diagrams for the structures, all these molecules, monosaccharides, have the same structural formula, which is C6H12O6, but all these molecules differ in their spatial configuration. They differ in the position of their hydrogen and hydroxyl in the space. So that's why they all are spatial configuration is different. They all are stereoisomers of each other. The next is the aldose sugar is option A glycerol, option B ribulose, option C erythrulose, option D dihydroxyacetone. The aldose sugar, which means that in which the aldehyde group is present. The right option is glycerol. If you can see here in this table, in the table given here, there are aldose sugars and there are keto sugars. These are the sugars which has the aldehyde group present in them, and these are the sugars which has the keto group present in them. So glyceraldehyde, it has the aldehyde group present in them, while the other ribulose, it is keto sugar, erythrulose, it is also the keto sugar, and dihydroxyacetone, it is also the keto sugar. So the right option is glycerol, glycerose, which is also known as glyceraldehyde. It contains the aldehyde group present in it. Which among the following is a triox sugar? The other one is option A for this question is glycerols, option B is ribose, erythrose, and D is fructose. The right option is glycerose. As the carbohydrates, especially the monosaccharides, are classified on the basis of functional group attached, and they are also classified on the basis of the number of carbon atoms present in them. So the question is asked triose. It means that 3 carbon atom, the sugar which contains the 3 carbon atoms. So that's how it is known as triose. If you can see here in the table, here are given trioses, tetroses, pentoses, and hexoses, as they are classified on the basis of number of carbon atoms present in them. The glycerol is trioses. Glycerol is a monosaccharide which is made up of 3 carbon atoms. So that's why the right option is glycerose. The other ribose is a pentoses which contains the 5 carbon atoms, and similarly fructose, it is a hexoses which contains 6 carbon which contains the 6 number of carbon atoms present in it. So that's why the right option is glucose, which is a trioses. The other question is a pentose sugar is option A dihydroxycetone, B ribulose, C erythrose, D glucose. The right option is ribulose, a pentose sugar, which means that it is a sugar which is made up of 5 carbon atoms. If you see here in the table, this is the pentoses, which contains the 5 number of carbon of atoms. So ribose and ribulose, these are pentoses. And the other options, if we see dihydroxycetone, it is trioses, erythrose, right here it is tetroses, and glucose, it is hexoses. Question number 6. The pentose sugar present mainly in the heart muscles is which among of them the sugar or the monosaccharide which is present in the heart? Option A lactose, B ribose, C arabinose, D xylose. The right option is lysose. This lysose sugar is present in the heart muscles, where it helps to protect the heart from the damage by the inflammation. It also improves the blood flow to the heart, and they also help in to reduce the risk of heart arrhythmias. Question number 7 is which among the following is polysaccharides? Option A is polymers, B acids, C proteins, D oils. The right option is polymers, as polymers are made up of many similar units. Polymers, it can be similar and sometimes they can also be different. So polymers are made up of many smaller subunits combined together are known as polymers. So polysaccharides are basically the polymers. Here you can see these molecules, these are the polymers. These are the polysaccharides: amylose, starch, glycogen, and cellulose. And all these polymers are made up of the same monosaccharides units. These are made up of glucose units. These glucose units are joined together in all these different are joined together in different linkages, and the number also varies. Sometimes they are also combined with different numbers of glucose units. So these many smaller molecules, when they combine together, they form the polymers, and these polymers are known as the polysaccharides: amylose, starch, glycogen, and cellulose. These are the examples of the polysaccharides. Question number 8 is the number of isomers of glucose is that how many isomers are possible by the structure of glucose. As if you can see here, this is the structure of the glucose. How much isomers are possible? It means that how much structural differences may be present, may be given by the glucose molecule. For this, there is a calculation for determining the isomers of glucose. The formula is number of optical isomers equals to 2 raised to power n. What is n? N is the number of chiral centers. What is chiral center? Chiral center is the central carbon which is attached to 4 different groups. If you can see here in the structure of glucose, you will be able to understand easily. This is the structure of glucose, which is made up of 6 carbon. This is first, second, third, fourth, fifth, and sixth. 6 carbon atoms. And these 6 carbon atoms, if you see here, this carbon is attached to 4 different groups. This is first, this is second, this is third, and this whole is fourth group. So this carbon is attached to 4 different groups. This carbon is attached to 4 different groups. This one, this one. This one is also attached to this one, this whole, and this one. So these 4 carbons are the chiral carbons. These are chiral carbons because they are attached to 4 different groups. Now the N is 4. If we put it into the formula, 2 raised to power 4 equals to 16. If we multiply 2 4 times, 2 into 2 4, 4 into 2 8, and 8 into 2, it will give rise to 16. So the right option is 16. The number of isomers of glucose is 16. Question number 9. Two sugars which differ from one another only in configuration around a single carbon atom are termed A. Epimers, B. Anomers, C. Optical isomers, D. Stereoisomers. In these options, we have to see which of the following is only differ in only one single carbon atom, in which it differs at only one position, that are known as epimers. If you see here, this is the structure of the glucose and this is the structure of the mannose. Mannose and glucose, they all are structurally same, only except for the position number 2. If you see here, there is a difference in rotation for the hydroxyl ion. For glucose, the hydroxyl ion is present on the right side, while in mannose, the hydroxyl is present on the left side. So this spatial configuration differ at only one single point. We can say that mannose is epimer of glucose at carbon number 2. Similarly, if we see galactose, galactose also differ at only one single point, that is carbon number 4. All the structure is similar, but the difference only occurs at this carbon number 4. Here the hydroxyl group is on the right side, while here in the hydroxyl group is present on the left side. So we say that galactose is epimer of glucose at carbon number 4. Question number 10. Isomers differing as a result of variations in configurations of the hydroxyl and hydrogen on carbon atoms 2, 3, and 4 of glucose are known as option A. Epimers, B. Anomers, C. Optical isomers, D. Stereoisomers. The right option for this question is epimers, as they have asked for a single carbon rotation, but they ask for the different carbons, that some of the monosaccharides, they may differ in configuration at carbon number 2, some may differ at 3, some at 4, that only the configuration variations in hydrogen and hydroxyl. If you see here in this is the structure of the glucose, carbon number 1 to carbon number 6. These are labeled. And if we see the number 2 example is mannose. Mannose differ at only carbon number 2. So mannose is epimer of glucose at carbon number 2. There is only variation of hydroxyl group at carbon 2. Similarly, if we see 3 example is allose. If we see that allose, it has the similar structure with the glucose, but it only differ at carbon number 3. Similarly, galactose, it differs at only carbon number 4. If we see the configuration of the hydrogen and hydroxyl ion, it differ at only one disposition. So 2, 3 and 4, the right option is epimers. Question number 11 is alpha D-glucose and beta D-glucose are option A. Stereoisomers, B. Epimers, C. Anomers, D. Keto-aldo pairs, and the right option is anomers. Alpha D-glucose and beta D-glucose are known as anomers. If you see here in these structures, alpha carbon and the alpha glucose are known as in which the position of the hydroxyl group is below this functional group. So this is the alpha carbon. If the hydroxyl group or the functional group is above, then it is known as beta. So alpha in which hydroxyl group is below and beta in which the configuration of the hydroxyl group is above. In structure, in ring structure form, and in open chain form, if we see here in Fisher projections, if the hydroxyl group is present on the right side, it is alpha, and if the configuration of the hydroxyl is on the left side, it is beta. So the right option is alpha glucose and beta D-glucose are known as anomers. And this MCQ can be asked in a reverse form, that anomers are, and the option might be given different one, but you have to choose that alpha glucose and beta glucose, alpha and beta form are known as the anomers. Question number 12 is alpha D-glucose plus 1120 plus 52.50 plus 190 beta D-glucose. For glucose above represents option A. Optical isomerism, B. Mutar rotation, option C. Epimerization, option D. D and L isomers. The right option for this is mutarotation. As if you see here in this question, there are some degree rotations. This is the linear form, this is the central form, and then when they become alpha, there is a variation in their angle, then this is alpha, and when 190 it becomes beta. So this conversion from alpha to beta and from beta to alpha, this property is known as mutarotation. This alpha is at this degree angle and beta at this degree. So this alpha, this is the linear glucose. When it changes the angle, it converts into alpha, that's in 36% cases, and when it changes the angle, it is beta and it is 64%. So this changes in angle from this linear form can convert into alpha and beta, and this conversion from alpha to beta and from beta to alpha, this property is known as mutarotation. Question number 13. The general formula of polysaccharides is A. C6H10O5 whole N, B. C6H12O5 whole N. There is option C and D, but the right option is option A, which is C6H10O5 whole N. As polysaccharides, they are made up of large number of monosaccharide units. These monosaccharide units join together by glycosidic bond and makes up the polymers of polysaccharides. And when these polysaccharides are hydrolyzed by enzymes in the presence of water, they again give rise to monosaccharide units. So they are made up of many monosaccharide units combined together to form polymer and polysaccharides. So for the right option is C6H10O5 whole N. This N represents the number of monosaccharide units present in the polysaccharide. For example, starch is a polysaccharide and the number of monosaccharide units may vary from 100 to 200. And similarly, the cellulose is also the polysaccharide. The N may vary from 1000 to 3000. Question number 14. In glucose, the orientation of hydrogen and hydroxyl group around the carbon atom 5. So it is the orientation of hydrogen and hydroxyl group only around 5. Carbon 5 adjacent to the terminal primary alcohol carbon determines that it must be attached to the terminal hydroxyl carbon. The option A is D or L series, B dextrorotatory, levorotatory, C is alpha and beta anomers, and D is epimers. The right option is A, D and L series. If you can see here in this diagram, there is this D glucose and L glucose. The rest of the structural formula is same and the chemical formula is also same. This is C6H12O6 and the structural formula is also same, but this is the terminal hydroxyl alcohol carbon, and this is 1, 2, 3, 4, and this is 5. If you see here, the hydroxyl group, if it is present on the right side, it is D glucose and L for the left. So when the hydroxyl group orientation on the left side, then it will be L form. So D when it is on the right side, and when it is on the left side, it will be L form. So D and L series are known as the orientation of the hydrogen hydroxyl group at carbon atom 5. The right option is A. We have also seen the alpha and beta in which the hydroxyl and hydrogen orientation was different, as alpha when the hydroxyl group is on the upside and on the downside, and beta when it is on the upside. In alpha it is on the right side and in beta it is on the left side. And epimers, we have seen that there was only the orientation at only single carbon atom and the rest of all were the same. But in case of DNL series, there is also a single orientation, but it is the specific carbon that which is attached to the terminal alcohol carbon. The other is left with dextrorotatory and levorotatory. Dextro, it is also represented with positive sign, plus sign. If I show you here, this is also represented dextro, if it can be represented as positive, it can be represented as positive sign, and levorotatory, it can be represented as a negative sign. Question number 15. The carbohydrate of the blood group substances is A. Sucrose, B. Fructose, C. Arabinose, D. Maltose. That which one among the following carbohydrates is found in the blood group? The right option is fructose. As if you see here in this diagram, galactose is also a carbohydrate, and acetylglucosamine and fructose. All these makes up the blood group antigens. As you see here the diagrams, O antigen, A antigen and B antigen. But in these options they have given only fructose, so we will choose the right option, that is fructose. This is the structure in which this fructose is present in these blood group antigens. So the right option is B, that is fructose. Question number 16. The sugar found in DNA is A. Xylose, B. Ribose, C. Deoxyribose, D. Ribulose. Which option is correct? That which of these sugar is found in DNA? In DNA structure, deoxyribose is present. If you see here in this structure, deoxyribose means D means removal of oxygen. Deoxy means D means removal and oxy means oxygen. In this sugar, if you see here, this is first prime, second prime, third prime, fourth prime and fifth prime. In case of DNA and RNA, we are concerned about only the second prime. If we see here in the second prime, there is only hydrogen present. The oxygen present here is removed. So that's why it is known as deoxyribose. In DNA, the sugar present in second prime, only hydrogen will be present. So the right option is deoxyribose. Question number 17. The sugar found in RNA is A. Ribose, B. Deoxyribose, C. Ribulose, D. Erythrose. The right option is ribose. In case of RNA, if you see here in this diagram, at carbon number 2, at second prime, if you see here OH is present, while in DNA only hydrogen was present. That's why that was known as deoxyribose. But in case of ribose, if you see here at the 2 prime, OH is present, so the ribose sugar is present in case of RNA. So that's why you can see here ribose. RNA in R stands for the ribose. Question number 18. The sugar found in milk. Option A, galactose, B, glucose, C, fructose, D, galactose. The right option is lactose. If you see here in this structure, lactose, they are made up of one glucose and other galactose structure. In the body, lactase enzyme is present, which hydrolyzes the lactose into glucose and galactose. There are, in some cases, the lactase deficiency occurs. If the lactase is not present in the body or not synthesized properly, it may lead to lactase deficiency, and lactose will not be able to hydrolyze. Then it leads to the indigestion of milk. Then in some children and in some people, they have milk indigestion. That is because of the deficiency of this enzyme, lactase enzyme. Question number 19. Sucrose, which is a disaccharide, consists of A. Glucose plus glucose, B. Glucose and fructose, C. Glucose and galactose, D. Glucose and mannose. The right option for sucrose is made up of glucose and fructose. If you can see here in this diagram, glucose and fructose, they are combined together by a glycosidic bond and they form the sucrose. The other MCQs, question number 10 is invert sugar is like which of the following forms the invert sugar? A. Lactose, B. Sucrose, C. Hydrolytic products of sucrose and D. Fructose. The right option is hydrolytic products of sucrose. Invert sugar is the hydrolytic products of sucrose. As we have seen that sucrose, it is made up of two monosaccharide units. Sucrose is a disaccharide. It is made up of glucose and fructose. If we see for their properties, as I already explained, dextrorotatory, in which there is positive sign, dextrorotatory and levorotatory. Dextrorotatory in which there is positive sign and levorotatory which has the negative sign. It is a property used for if we take a solution of the glucose or the carbohydrate, and then the light is passed through the solution, these monosaccharides have the property to rotate the plane polarized light into the different direction. So when the plane polarized light is rotated 66.5 degree, it is known as dextrorotatory. When it is rotated to the right side, it is known as dextrorotatory, and when it rotates to the left side, it is known as levorotatory. So based on these properties, they are known as dextrorotatory and levorotatory, and they are represented as small d and small l, positive and negative. When it rotates the plane polarized light to the right, it is dextrorotatory, and when it rotates the plane polarized light to the left, it is known as levorotatory. So here there is a concept here that sucrose, which is dextrorotatory, when it is broken down in the presence of water and hydrogen ion, it gives rise to glucose and fructose. Now we say that when the dextrorotatory sucrose is converted into levorotatory, then it is known as invert sugar. Why it is known as invert sugar? There glucose is also present, but the rotation of levorotration, that is minus 92 degree, while the glucose gives the 52.5. So this levorotatory is more. So we say that dextrorotatory solution is converted into levorotatory. So that's why it leads to the property known as invert sugar. And these are the hydrolytic products of sucrose. That sucrose, when they're hydrolyzed, it gives rise to the dextro, gives rise to the levorotatory molecule. Question number 21. Monosaccharide units are linked by 1,4 glycosidic linkages in option A maltose, B sucrose, C cellulose, D cellulose. The right option for this question is maltose, as maltose is a disaccharide, and disaccharides are those carbohydrates which are made up of 2 monosaccharide units. So in maltose, they are made up of 2 glucose units. Maltose is made up of glucose and glucose. You can see here this glucose carbon number 1 and this glucose carbon number 2. Their hydroxyl groups joined together. There is oxygen present in them. This bond is known as glycosidic bond, and the linkage is 1,4 glycosidic linkage. And this is in the alpha form. This is in the alpha form. So that's why they are known as alpha D 1,4 glycosidic linkages, and the right option is maltose. Question number 22. Which of the following is a non-reducing sugar? A. Isomaltose, B. Maltose, C. Lactose, D. Trehalose. The right option is trehalose, as trehalose is a non-reducing sugar. So let's first talk about the concept of non-reducing sugar and reducing sugars. Non-reducing sugars are those sugars, as the name indicates, that cannot be reduced further. As in this case, trehalose, if you can see here at carbon number 1 and at carbon number 1, they mix the bond, so their functional groups and their hydroxyl groups are not exposed to be further hydrolyzed or to make further bond and to bind with another monosaccharide units. So that's why they are non-reducing sugars. They cannot be further reduced by another monosaccharide units. And similarly, these other are the reducing sugars, lactose, maltose, and isomaltose. It means that they may have the functional group may have the free hydroxyl end, which would be able to bind with other monosaccharides and would be able to be reduced. Now in this question, it is asked for the reducing sugars, that which of the following is a reducing sugar? A. Sucrose, B. Trehalose, C. Isomaltose, D. Agar. The right option for that which one of the following is a reducing sugar, isomaltose is a reducing sugar. If you see here in this structure, isomaltose is made up of glucose and glucose. There is the linkage alpha 1,6. This is the first and this is the 6th. So the hydroxyl groups, they combine together to form the glycosidic bond. But if you see here, this first carbon, the hydroxyl and the functional group, it is free. This hydroxyl group is free and it can be further hydrolyzed, that because the linkage is alpha 1,6. So this first carbon can again form a linkage with the other glucose molecule of having the 6th carbon atom, because there is the 1,6 linkages. So it means that it can further hydrolyze with the 6' of another glucose, and then so on. So isomaltose is a reducing sugar. Similarly, sucrose and trehalose, it does not have the free hydroxyl end that is required for the possible bonding. So that's why they are non-reducing sugars. Question number 24. Disaccharide formed by 1,4 glycosidic linkage between their monosaccharides. Again, it is asked that which of the disaccharide that is formed by monosaccharide units that have the 1,4 linkages, and the right option is maltose. As I already discussed about maltose, that maltose have the 1,4 linkages and it has the alpha 1,4 glycosidic bond. Then this is the maltose. This is the first carbon, this is the fourth, this is the first carbon, this is the fourth carbon, it has the hydroxyl group. Then what? There will be the release of water molecule, and this is the glycosidic bond. Then it forms the glycosidic linkages. Then the right option is maltose. Here the last MCQ. A disaccharide formed by 1,1 glycosidic linkage between their monosaccharide unit is, I think it is again, we have already discussed about non-reducing sugars, that is trehalose, in which there is 1,1 glycosidic linkage and they are formed by this bonding, and when they are bond, it cannot be further bind to another glucose unit, so that's why they are non-reducing sugars, and 1,1 is present in trehalose. In this video, just few MCQs were explained. There are some other videos in which other MCQs on carbohydrates are also explained in detail. Don't forget to watch these. If you like it, don't forget to watch other videos. Thank you.